Okay, so this video it's related to stuff that we've done in chapter 2, except now we're actually solving specific equations instead of just graphing them. So I'm going to take you through a couple examples in each video, which, I don't know, probably 3 videos total, and I'm guessing maybe 10 minutes each video. So some of these I'm guessing you could probably already do. So I'm just going to go through them and kind of, if you have any questions, make sure to ask me in class. Okay, so the first one, it's x plus 3 over x equals 4. One thing that's always a good idea to do right off the bat is over on the side, state your domain. So in this case, the only domain restriction comes out of there, and it's x can't be 0. So it's everything but 0. Now, in order to solve this problem, one good strategy would be to try and get rid of the fractions. So if I multiply everything on this side by x and everything on that side by x, so let me write that out. X plus 3 over x equals x times 4. Then I can multiply this. So I distribute the x on the left and I get x squared plus 3 equals 4x. Now I can bring the 4x over to the other side, and I'm going to write it this way with the negative 4x in the middle because this is one that can be factored. So I get x minus 3, x minus 1 equals 0. So x is going to be 3 or x is going to be 1. And in this case, they both work. They're not zeros, so my answers are valid here. And you can check them pretty quick, right? So if I check and I plug in x equals 3, I get 3. So let me put here x equals 3. So 3 plus 3 over 3 equals 4. That's definitely true. If I check x equals 1, 1 plus 3 over 1 definitely equals 4. So that works too. Okay, so these are my answers here, 3 and 1. If we move on to example 2, 2 is just a more complicated type of problem in that now I've got a couple denominators that both have x terms and then one slightly uglier one. So in this one, if you can actually factor this denominator, whoops, it was the same denominator that we had in the previous problem, the same quadratic, I mean. So that denominator is x plus 3 to x minus 1. And if you write your domain restrictions over on the side, it's x can't be 1 and it can't be 3. I get can't be 1 from there, can't be 3 from there, and this doesn't add anything new. So let me rewrite this here. 2x over x minus 1 plus 1 over x minus 3 equals 2 over x minus 3, x minus 1. Okay, so if you hadn't figured it out, probably the best way to deal with this is to bust it, as Mr. Omashny would say. So I'm going to multiply both sides by x minus 3, x plus 1 in order to get rid of this whole denominator. So x minus 3, x minus 1, and this whole side by, ooh, am I going to have room here? X minus 3, I'll just cram it in here, x minus 1. Okay, so if I multiply this term by both of these, then the x minus 1s will cancel, and I'm left with 2x times x minus 3. And then if I multiply this term by both of these, the x minus 3s will cancel, and I'm left with 1 times x minus 1. And then over on the right side, both of these terms are going to cancel, and I'm just left with 2 there. So now if I multiply stuff out, 2x squared minus 6x plus x minus 1 equals 2. And then if I bring everything over to one side, I should get 2x squared minus 5x minus 3 equals 0. This also factors by hand. If you can't figure out how, you can always use quadratic formula. So this is going to turn into 2x plus 1 times x minus 3 equals 0. And so then we get x equals out of this. You either set this equal to 0 or this equals 0. So if this one equals 0, you get x is negative 1/2. Or if the other one is 0, then you get x equals 3. So it looks like we get 2 answers. But remember to check against your domain here. x can't be 3, so this guy doesn't count, right? Not in domain. So let's check over here, x equals -1/2. And if you plug that in, let's see, what do we get? We get 2 times -1/2 over -1/2 minus 1 plus 1 over -1/2 minus 3 equals 2 over, we're checking if this is right, so I'm going to put a question mark right there over the equals, 2 over -1/2 squared minus 4 times -1/2 plus 3. And really, you know, if you want to check it by hand, you can, but you can just plug them into a calculator, plug in this side, and you should get the same values on both, so they are equal. Okay, so this one does work. This one does work. Okay, I'll do one more example on this video because this one's a little more complicated, example 3, and then I'll switch over to other videos. So how much pure acid has to be added to 50 milliliters? Oh, by the way, I realize that for those of you who are in chemistry, there's really no way of actually getting something that's 100% pure acid, but whatever. Okay, so how much pure acid must be added to 50 milliliters of a 35% acid solution to produce a 75% acid solution? Okay. So you start out with 35% and you have to add acid until you get exactly 75% acid. So it helps to kind of break down this problem a little bit. Percent acid in a solution is really going to be the amount of acid that you have divided by the total amount of solution that you have. And I think that should kind of make intuitive sense there. So the way to think about this, what we originally start with is 35% of 50 milliliters is acid, right? Because we have originally 50 milliliters and it's 35% acid. So that means that the amount of acid that I originally have is 0.35 times 50. That's how much acid I originally have. And that's originally out of 50. And if you cancel those, then you can see you have 35%. But what I'm doing is I'm adding pure acid to it. So however much acid I'm adding here, I'm also adding here, right? So so this, let me write this, where X represents, let's see, the amount of pure acid added to the solution, right? Let's see. Yeah, so this right here is 17.5. So originally I have 17.5 milliliters of acid in my 50 milliliter solution. So if I add X, you know, milliliters of pure acid, then I've got 17.5 plus X out of 50 plus X. By the way, so this is what we're looking at, and we want that to be 75%. So I want to set this equal to 0.75, 75%. Okay, domain. So domain, I know that X can't be -50, but really that's sort of a ridiculous domain for this problem because I can't add -50 milliliters of solution. So really, instead, you want to think of the domain as X has to be greater than or equal to 0 because X is what I'm adding, and the least I can add is nothing, and everything else that I could add has to be a positive amount of solution, of acid. So this is my domain, right? So this is really the idea here. Okay, so let's work with this full equation right here, 0.35 times 50 plus X over 50 plus X has to equal 0.75. And I'll simplify this numerator here. It's 17.5 plus X over 50 plus X. equals 0.75. Okay, so now what I could do is I could bust the fraction, so I could multiply both sides by 50 plus x. So then this is going to turn into 17.5 plus x equals 0.75 times 50 plus x. I'll move this over here now. So if I distribute that 0.75, I am going to get, let's see, that'll be 37.5 plus 0.75x. Now if I get all the x terms on one side, this is 1x here. So if I subtract the 0.75x, I'll get 0.25x. And if I bring the 17.5 over to the other side, I'll get 20. And so if I divide everything by 0.25, I end up with 80. So this suggests that I should add 80 milliliters of acid, because x was the amount of acid that I add. And it's positive, x is positive, so that's good, it's in my domain. And if I do a quick check, 80 plus 0.35 times 50, I probably should have switched those to make it look more like the other side, but over 80 plus 50, that does in fact equal 0.75, so we're good to go. Okay, so I'll stop there and then I'll do a couple more examples in the next video. Okay, hope that helps.